Okay, good morning from the IFSM and welcome to today's webinar, Firestopping, a Guide to Getting It Right. This CPD webinar will be delivered by Aaron Gardiner. If there are any disconnections, please attempt to reconnect and you'll get back in ASAP. The webinar will be recorded and it can be accessed through the IFSM website. The session will last approximately 1 hour. Please be aware that those watching a recording of the webinar will not be able to apply for a CPD certificate, so CPD for only those watching live. We would like all attendees to ensure mics are off. Please feel free to ask questions using the Q&A feature at the top of Teams. Aaron will try to go through some of these at the end of the webinar, time permitting. You will be issued with your CPD certificate on completion of the feedback form, which will be available in the chat at the end of the webinar. Please try to complete this before closing Teams. It will only take a minute and it will help us to get your CPD certificate out to you promptly. CPD certificates will only be issued on completion of the feedback form. The link will be pinned at the top of chat towards the end of the webinar. Aaron has been in the fire protection industry for 17 years, working for several major passive fire protection manufacturers and a UCAS accredited test house. He has worked on specifications and installation details for numerous large construction projects, including the Shard, Houses of Parliament, Battersea Power Station, and the Cheese Grater. He holds a diploma in fire stopping inspection and an Institute of Fire Engineers Level 3 in passive fire protection. I will now hand over to Aaron. Thank you very much.
Very much, Stephen. So that was a very nice introduction. So my name is Aaron Gardiner. I'm the National Specification Manager for Nullifier, which is part of the Tremco CPG group. So we'll get started. A little bit about the agenda and what we're going to touch on today. I'm going to try and not teach to suck eggs too much on this, but we're going to look through the Building Safety Act, the gateways and the golden thread of information section. We'll then touch on fire science elements, so looking at compartmentation, reactions, etc. We'll look at testing and details, a little bit more of a deep dive into the substrates and service types and some of the questions that we would need to know as a manufacturer. And then we'll touch on some other elements as well that keep coming up on projects and sort of areas that are causing issues within the industry at the moment and sort of how to try and overcome those. So we're looking at service spacing, builders work openings, and finally deflection. And then obviously I will try and answer as many questions as I can towards the end of this. So looking at the Building Safety Act, the gateways and golden thread. Now, the Building Safety Act, as you probably are all very aware, became mandatory UK law in 2022, and it's based on the findings of the recommendations from the Grenfell inquiry. It's relevant to all high-risk buildings, at least 2 residential units or greater than 18 metres in height, and can include also hospitals and care homes. So it's basically replacing the traditional planning process through a number of what we call defined gateways. And each gateway requires developers to submit quite a large amount of documentation and reassurance, whether through detailed safety plans, fire and structural safety checks, construction change management competencies, and obviously compliance. So the information that's assessed at each gateway by the new Building Safety Regulator, or BSR, now, they form part of the Health and Safety Executive as well, or HSE. Now, because of this introduction, it can cause delays as work basically can't commence until the acceptances have been granted from the BSR. So any major changes need to be submitted to the BSR and they need to be reapproved. Even minor changes are subject to a prescribed delay period. Now, the other thing as well is the handover of information as built on completion, which is Gateway 3, also includes all of the golden thread information. Now, at the end of that, you'll also get a certificate, or a certificate is required. And the golden thread of information, essentially, it's a permanently digitally stored record of all the relevant information, documents for the building compiled and verified at each gateway stage. So this also includes the provision of like accurate product information, testing, compliance, and also certification. And that data is maintained throughout the lifetime of the building and updated to record any future changes as well. Oops, sorry. Now this slide is, I've pinched this slide, so this isn't my slide, but it's quite a good overview of the whole process, and it breaks down the range of elements and the people that are involved in these gateway stages. So as you can see at the top, the building safety regulator implements and essentially enforces a more stringent regulatory regime throughout the whole life cycle of the building. We then also have the principal designer, and they're appointed by the client to plan, manage, and coordinate and monitor the pre-construction phase where the design work is most onerous. The principal contractor is also appointed by the client, and that ensures the design and the plans are coordinated and monitored during the construction phase. And then finally, as I've already mentioned, throughout all of the gateway phases, the golden thread of information is digitally recorded and captured, capturing all of the data information provided throughout all of the process and all of the gateway stages. Now, again, I'm not trying to do this as a sales pitch, but as part of what we do and what I do as my role is try to get early engagement with the design teams and with the main contractors. And essentially, what we're trying to do is look at all the potential risk areas, the potential problem areas from design, and in terms of ensuring essentially the architects are not fire stopping specialists, the main contractors are not fire stopping specialists, and what we're trying to do is guide them through lots of common things that we face and issues that we come up against, and trying to make sure that the process is as smooth as possible and giving them all of the data and all the information that they need to input into the golden thread element of the BSR application as well. So now we've got all the fun stuff out of the way, we're going to start looking at the fire science. Now again, compartmentation's something that you'll probably quite regularly hear when you're talking about fire. And essentially, a fire compartment is a building or part of a building comprising of one or more rooms, spaces, or stories, and it's constructed to prevent the spread of fire to or from another part of the same building or an adjoining building. The simplest way I put this when we're explaining to people that aren't in the industry is essentially we're trying to create a smaller box within a bigger box to stop the fire spreading throughout the big box, essentially. Now, the basis of compartmentation, as I've just touched on, is to subdivide those buildings into areas of what we call manageable risk, and to provide adequate means of escape and to provide fire separation for adjoining buildings. Now, to achieve that, we need a measure of control called fire rating, and we'll touch on that in the next couple of slides. One of the other things that commonly we get asked questions on is the discussion on reaction versus resistance. So, whether you're a contractor, an engineer, or an architect, the two terms can often be quite confusing, but there is an important distinction between the two. So reaction to fire evaluates the specific materials contributing to fire, whereas resistance to fire assesses a system's ability to resist the penetration through the system or the products and prevent the temperature rise between the exposed and the unexposed sides in a fully developed fire situation. So again, looking on the screen here on the image, reaction to fire is usually measured at this very sort of early stages of the development of the fire. And then we have what's called the flashover point. And the flashover point, I always kind of describe it as, one of the Die Hard films or one of your action films where essentially the fire is igniting all of the combustible gases, all of the elements in that room. The fire is rolling across the ceilings at that sort of point, and the fire is then starting to grow into what we call the fully developed stage. It's at this fully developed stage where the resistance to fire is then measured. So to touch on the reaction to fire a little bit more, as the name suggests, it's the material's reaction to fire and its indication of how it responds to fire as well, so whether it flares or contributes to the spread of fire. So reaction to fire, essentially, when we're doing fire testing for this, it evaluates the construction materials, as I mentioned, contribution, and again in the early stages, and they can be classified into 7 different Euro classes according to the way that they react to the fire. Again, I'm not going to kind of go into too much detail, but for example, an A1 rated product states that it does not fuel or contribute to the fire. And these progress down. So we have A2, B, C, D, E, and F. So for example, D rating classes as fuel, it causes flashover before 10 minutes. E, fuel causes flashover before 2 minutes, and then an F is an in detriment behavior, and materials and products are untested. As part of the reaction to fire test as well, you also have to look at the smoke opacity, so how much smoke does it give off. You also have to look at what we call flaming droplets or particles. So again, does it drop particles, and are they inflamed, and how much of that it's given off. Now, the resistance to fire, again, the product's resistance to the fire and how well it performs containing that fire from breaking through or breaching. And there are also several other elements. So resistance to fire is measured according to 3 criteria. So it's supporting capacity, integrity, and insulation. And we'll touch on this on the next slide in a bit more detail. So as I've mentioned, fire ratings expressed in 3 measures. We have load bearing capacity, and these are sometimes shown as letters. So load bearing capacity is represented by the letter R, and this is the load bearing capacity or supporting capacity, and this looks at the constructed element to resist mechanically without losing its structural properties, or put another way, the period of time before a structural element loses its capability in a fire scenario. We then have integrity, which is represented by the letter E, and this is probably the one that's most commonly thought of when we're talking about a fire-resistant product. Now, this is the capacity of the product to prevent the passage of fire and hot gases into an area not affected by the fire. So this is looking at how long it takes for physical flaming to pass from the fire side to the non-fire side. Now, again, in a fire scenario, when we're doing fire tests, we use what's called the cotton wool test scenario. And essentially, it's very high tech. It's a big ball of cotton wool on the end of a very long stick in a cage. And if there's any kind of signs of breaches, they hold that cotton wool up against the area that looks like it's glowing or breached. If that ignites within a minute, then it's a failure of that product during that test. We then finally have insulation, and this is represented by the letter I. And this is the capacity of the product to prevent the temperature increase in the face not directly exposed to the fire, otherwise described as the resistance to transfer of excessive heat. So its ability to provide insulation from high temperatures. Now, this is the one that's most commonly forgotten about or not understood as well in the fire industry. So what we're saying is, if there is a fire on this side of the wall, what we're trying to do with fire stopping products is trying to keep this temperature below 180 degrees Celsius, is the average, the highest temperature that one of our thermometers when we're doing the tests can reach. Now, again, one of the important things to remember is our products, or fire stopping products in general, are designed to reinstate the fire rating of the compartment wall or floor that it's being installed into. So if you have a 60-minute wall, the highest fire rating you're going to achieve is 60 minutes, nothing more. Okay, we get asked quite a lot, oh, I've got a 60-minute wall, but the client's asking for a 120-minute fire rating. Unfortunately, if the wall disappears, then the fire stopping also disappears with it. Now, these 3 measures of fire ratings are defined in fire testing standards as well. So the fire testing standards most manufacturers will test to now is EN 1366, parts 3 and parts 4. Part 3 is the service penetration test standards, and part 4 is for linear gaps, so small gaps, edge of slab and things like that. So we'll look at testing and details now. So as a manufacturer, we will carry out quite a large number of tests every year. So once we design and we install the fire test, we will burn this at a UCAS accredited laboratory. Once the test has been completed, we are then issued with a test report or raw data. Okay. Now, the test reports or raw data are generally very complex. They have lots and lots of graphs and tables with lots and lots of information that, in a lot of cases, don't mean a lot to the average Joe on a construction site. We generally only issue these out to fire engineers, and they will be under an NDA, a non-disclosure agreement. Once we have the test reports, we then issue those, or we then transfer these into what's known as a certification document. So these can be, again, from a number of different bodies, and they're usually seen as like a certified document or a European technical assessment from UL, for example. Now, the biggest sort of issue in the industry at the moment is the time frame of this whole process. So from start to finish, at the moment, if you said today, I would like to test a specific scenario on site, this whole process can take anywhere from 2 to 3 years at the moment. So you're looking at about 6 to 9 months to get into the furnace, and then probably about a year to 18 months before you get the test report back, and then probably about another 6 to 12 months for the certification document to be issued. So it's quite a frustration within the industry at the moment. And again, when we get called onto site and they say, "Oh, can't you just stick it in the furnace and test it?" Unfortunately, it's not a quick turnaround, and it's not cheap as well. Now, once we've got the test reports back and the certification documents and things like that, as a manufacturer, we will issue what's known as a tested detail and drawings that they can be referred to. And this will give information on how the product was installed, the size of the services, the fire ratings it was achieved, lots and lots of different information that should be adhered to, and it should be checked very rigorously before it's being installed to make sure it complies with the regulations and it's compliant with the installation. Now, as much as I'd like to sit here and tell you that every single site that we go onto, a tested detail is available and a tested detail can be applied as it's been built exactly as we would expect it to. Obviously, our biggest thing, our biggest sort of motto is always saying to clients, to architects, to installer teams, wherever possible, you should always adhere to a tested solution and a tested detail. Now, obviously, that isn't always the case, and we appreciate that there's always things that come up on a construction site that is unforeseeable, especially on like remediation projects or historical projects where we can't just rip out services and realign, letterbox openings and things like that. So, as I've sort of touched on, tested solution is always the option you're looking to achieve. There's an ad hoc detail, which is basically a small deviation from the test. So again, it may be a slightly larger opening or a slight deviation in terms of the pipe goes through at a slight angle, for example. So they're minor deviations from the testing. What we will then look at, or some manufacturers will look at, is a technical evaluation. Now, a technical evaluation, you may sort of know them as, they used to be referred to as engineering judgments. Now, this is where you have multiple deviations from a test and where essentially a manufacturer will offer their opinion and provide evidence in some cases from multiple test reports to offer a solution. Now, this type of offering will be specific to the project and it will always follow the PFPF guidelines. Now, a fire engineer will usually need to be involved to review and assess these as well, as it's just an opinion. So us as a manufacturer, we are not fire engineers. We will provide we will provide our opinion and say that in our opinion, we believe this will work based on X, Y, Z evidence. And it will be then the fire engineer that will look at that and assess it. And they will sort of look at the risk factors involved in that. A lot of clients and a lot of contractors are trying to pull away from this, which is great news, and it means that we're heading towards a more compliant sort of option on site. But the reality is we're still seeing technical evaluations being used on projects across the UK. We finally then have what's known as a best endeavours. Now, best endeavours is obviously not the most ideal, and this is where no test evidence is available and site conditions can't be changed to suit what we would require. It's usually a last resort, and it's where some form of fire stopping will be better than nothing at all. And again, this should be avoided wherever possible, however. We're going to look at the substrates and service types. Now, again, there are many, many different types of substrates that we come across on projects, from your standard, brick and block work to your dry lining systems. But there's lots of different variations that we have to take into account. So a drywall system is not the same as a shaft wall system. Shaft wall has a different testing recommendations as opposed to a symmetrical wall design. The wall thicknesses, how is the opening formed? Is there a cavity in the blockwork? Is it framed and lined? Is it a profile deck? Is it CLT? Is it Metsec? Timber studs? All these different variations come into play when we're looking at specifying and offering a tested solution. So it's very, very important that the wall thickness, the substrate materials, the opening types, all these things are considered when we're looking at this, as it will have a massive effect on how we advise on what is tested, what the fire rating is. Things like, is it core drilled? Is it, as I said, is it framed and lined? All these things are a major, major impact on the different scenarios that we can offer to you. We then come on to the service types. And again, if I had a pound for every time someone says, I've got a plastic pipe going through a wall and I need 60 minutes, what can you do? Now, unfortunately, combustible plastics and combustible pipes, there are a huge range of different variations in the plastic materials and plastic types that we come up against. So, is it PVC? Is it HDP? Is it PE, PP, PPR, ABS, PEX? All these different variations. Again, lots of different plastics will have different melting points. So some will melt a lot quicker than others. Some will have, aluminium metal linings inside them. They may be flexible. Lots and lots of different things that we have to take into account. So some may use a collar. Some may need to use high pressure mastics around them. Strap may work better. There's lots and lots of different things that we need to consider with this. Similar with like lagged non-combustible pipes, or even lagged combustible pipes in some cases, we need to know, what is the lagging type? Is it phenolic? Is it nitrile rubber, rock fiber, glass wool? Again, rock fiber is classed as an A1 non-combustible material, but in reality, even though it's A1 non-combustible, it doesn't burn or it doesn't sort of melt away. But in a fire scenario, it actually can shrink. It sort of essentially puckers up as it gets hot. So we have to then look at the fact that, will this pull away from the mastic? Will it create a potential breach through the fire seal if that shrinks and creates a tear between the mastic and the lagging itself? Again, similar for non-combustible systems, cable trays, steel pipes, copper pipes. Copper pipes will transfer heat incredibly effectively. So again, if you have a bare copper pipe with no kind of lagging on it, it will transfer the heat incredibly well. And in most cases, you won't get above a 15-minute insulation rating, for example. So additional lagging needs to be added onto these types of pipes. Again, cable trays may need to be lagged sort of 200 to 500 mil away from the face of the wall or from the face of the seal. All these things we need to consider in terms of, do they bend quite quickly after they come out of the opening? Is there a connection? Is there a pipe connector in the lining of the wall? Again, we want to make sure that the pipe connections are not sitting in the lining of the wall. And again, cables. So lots and lots of different variations of cables. Copper core, fiber optic, glass cord cables. All these different elements of cable types. The size of them as well will also have a huge and detrimental effect on the fire performance. So these things we need to know when we're looking at these, looking at this from a detail perspective. And again, we'll touch on some more of these elements as well. So the spacing of services, I know M&E, we used to, again, predominantly up until the last sort of 2 years or so, it was generally we were called in as the sort of last element of the design stage or last part of the construction phase, and we generally have to work around what the M&E had tried to do, and they generally will try to fit as many services through a small opening as possible. But what that does is it creates huge amounts of problems for us as a manufacturer to provide evidence in the distance of spacing. Again, diameters, the wall thicknesses of the pipe, and also the lagging. Again, chemical compatibility, and I'll touch on this in the next slide, especially with some of the plastic types, and also the fire rating required. We get asked countless times, "Oh, we need a detail for an installation," but they don't even know if they need 60 minutes. They don't even know if they need E and I or REI ratings on the seal as well. So again, in normally as a sort of worst case scenario, we will always try and offer an EI rating unless we are specifically told it doesn't need to achieve the insulation rating, for example. So as I've touched on, chemical compatibility with some plastic pipes. Now I touch on this, I think it's becoming more widely spread, known within the industry. There are sprinkler systems known as CPVC pipes. Now, generally, they are generally this sort of orange colour, as you can see on the screen at the moment. Now, there are two main manufacturers in the UK, that is Lubrizol and Spears. Now, they have what's called a compatibility approval list. Now, we will always, again, we've drummed this into all of the fire stopping contractors, and we're trying to educate the market as well with the main contractors and architects. CPVC are extremely they can be very reactive to a lot of different elements that you'll find on a construction site. So I could list off lots and lots. There's lots of white papers out there as well on this specific service type. But if you touch them with your bare hands, if you've got any grease or sweaty palms, that can eat through the plastic. If cables are touching it, so the plastic sheathing on cables, the plasticizers in that product can actually leach through the CPVC and cause blistering or hairline cracks. And obviously mastics from fire stopping materials are very, very reactive to this type of product. Even rubber couplings, if you see rubber couplings on CPVC, that's non-compliant, and that whole pipe would need to be changed. Again, I won't bore you to death with all the different things that affect this pipe, but we joke if you look at it in the wrong direction or say a bad word around it, then it can cause issues with this. Again, cost is a major effect of why this product is used over the old sort of carbon steel pipes that were more commonly used back in the day. So again, we're trying to make sure that all the following trades that follow afterwards are aware of the sort of potential issues with using CPVC sprinklers, and just making sure that they're aware and they're following all of the guidance from the manufacturers. Now, again, one of the other things that commonly comes up is fire-rated dampers and fire-rated ducts. We get asked a lot of the time have you got a detail for a damper or a duct? Unfortunately, we would spend the next 25 years and countless millions of pounds testing every damper and every duct on the market. So we will always advise you need to go to the damper or the duct manufacturer themselves, and you need to follow their tested guidance and their guidelines in terms of what their details show, in terms of how much space is allowed around the damper, what substrates they've been tested into, what fire ratings, etc., and what materials are used around them as well. Some dampers will use a fire-rated compound, even in walls. Some will use bats. Some will be encased in, calcium silicate boards or plasterboard boards, things like that. So again, it's very, very important that you follow the guidance from the damper manufacturer or from the duct manufacturer. The other important thing to consider when looking at these these service types is they are tested to a different standard than your usual service types. So, your cable trays, your pipes, your lag pipes, that kind of thing, are tested to, as we mentioned, 1366 Part 3 for service penetrations. Dampers and ducts are tested to Part 1 and Part 2 of 1366. Now, the reason I mention that is dampers and ducts must be in their own letterbox opening. They must not be in the same opening as a cable tray or a plastic pipe or something like that. They cannot be in the same opening, as it's then the two standards don't talk to each other and it becomes a non-compliant seal. Now, again, you'd be amazed how many times we see this on site, and we get asked, "Oh, can you provide an ad hoc detail for this?" Unfortunately, it's a non-compliant detail, and they would need to be moved out of the same opening. One of the other things as well, which has become a little bit more sort of apparent in the sort of last sort of couple of years, is service supports. Now, service supports are obviously very important to the M&E services that are passing through, and each manufacturer, fire stopping manufacturer, will provide their minimum service support distance required as per the test. Now, this can vary from 250 to 500 mil from the face of the wall. But there is also an argument that you must ensure that the M&E requirements are also met and it doesn't void their warranties. So again, something to kind of look at when you're looking at the manufacturer that you've chosen as the fire stopping installer, and also discussion, hopefully trying to get that early engagement before services are installed, and making sure that everyone's happy with the compliance of those first service supports. Now, service spacing. Again, service spacing can vary again quite wildly between manufacturer to manufacturer. And again, this is an example of something that we've put together to try and make it as simple as possible to follow. And again, it's about identifying what the service type is, how far away it needs to be from the edge of the substrate in terms of the actual opening itself, and then also looking at the spacing between each element. We would say, and the standards ask, for a minimum of 100 mil away from the edge and 100 mil away from each service. If you always have that rule of thumb of 100 mil away from the edge and 100 mil from other services, you will be absolutely fine and compliant. But again, whenever we mention this to architects and main contractor, they normally have a heart attack and say, "Oh my gosh, our openings are going to be huge and we'll never be able to build it, and we'll have to add 2 extra floors to the building to accommodate that." So this is why we've tested in some cases much closer together, even in some cases down to 0 mil. But again, this is where coordination between the fire stopping manufacturer, the architect, the MEP teams, and even in some cases the dry lining or the wall manufacturers is very, very important in terms of getting that early engagement and early design elements bottomed out. Now again, builders work openings. Now this is a quite a good example. So I've actually used the example from the British Gypsum Best Practice Guide. Now, builders work openings, especially in dry lined walls, for example, plasterboard walls. The sort of the aperture guidance, generally we would always say you need to follow the guidance from the wall manufacturer. So if it's BG or Knauf or Cineat, for example, they will vary from manufacturer to manufacturer. Now again, the example I've got on the screen at the moment says that in the British Gypsum guidance, each letterbox needs to be a minimum of 300 mil apart from each other. So this is from letterbox to letterbox, left to right, and they ask for 200 mil above and below each other, a free space between each letterbox. Now, there's other elements to consider into this. In the standards, in the test standards, we will be asked for a minimum of 200 mil between each opening. So we always say work on the worst case scenario. So if British Gypsum ask for 300 mil, or say Cinia asked for 150 mil, but the guidance from the manufacturer of the damper or from the service manufacturer asks for a 200 mil separation. Always go with the worst case scenario, so always go with the greater number. Now, one of the other things that is also a standard guidance is the letterbox must be 200 mil minimum away from the fire door. So that's above and below, left and right as well. Other things like cord openings, they only need to be 100 mil separation from each other or from a builder's work opening. So again, it's really, really important that this is adhered to and followed in terms of the manufacturers that you're using, because they will vary quite differently between the manufacturers available in the market. I know it doesn't help simplify things or unify things. And again, it's something that we as a manufacturer are bringing up with guidance with the ASFP, the Association of Specialist Fire Protection. And again, we're trying to make it more unified to make it a lot more simpler to follow within the industry. And then we touch on deflection, which is one of my favourite elements at the moment. And again, it's something that's probably a bit more of a new phenomenon within the industry. Now, again, as things get smaller and buildings are designed to be more compact and more efficient, etc., what we have, as you can see on the screen, is a three-sided letterbox. So this is where the architects, generally when they've got quite a high ceiling that they need to achieve, is they will try and cram lots and lots of services. This is actually quite a big one in this example, but they will try and put small letterbox openings tight to the soffit. So the plasterboard comes along, it finishes, and then you have what we call this three-sided letterbox where it drops down and comes up again. Now the problem is you've now created an opening within the deflection zone of that dry lining. And again, this is something that's it causes a lot of headaches because for years and years and years, deflection was never really thought about too much, if I'm being really honest. It was never a question that really came up from architects. And again, by the time the fire stopping went in, the live load of the deflection was generally already occurred. So the actual deflection that was happening at that point was generally slippage. So it was usually a couple of millimeters, and the back systems generally can accommodate a small amount of movement. Now, again, as things have developed, this has become more of a, I suppose, a common issue. And again, structural engineers will say a blanket 25 mil deflection, 20 mil deflection is the most common ones that are asked for across the project. And the three-sided openings now need to accommodate that. So you have a couple of sort of options here. So you have your soffit deflection. Okay, soffit deflection is essentially we're just looking at the soffit is moving up and down, and we need to consider that. The second stage of that is your services. Your services are connected by drop rods or service supports, as we've just touched on, and that is connected to the same slab, which is also moving up and down. So you now have an issue where the services are connected to the slab, which is also moving up and down. So we need to accommodate that movement within that letterbox and make sure the services move simultaneously with the slab in the fire stop opening. So there are a number of different options. Again, depending on the manufacturer, there is mineral fiber solutions, very low density mineral fiber solutions. There are solutions where a compressible incandescent sponge is fitted at the head. And again, this is the more new system that a number of manufacturers are looking at, where essentially we attach the fire stopped opening or fire stop seal to the slab, and then we essentially detach the fire stopping elements by using a compressible or movable sponge-like material around the outside. So essentially the deflection zone continues along here and then it drops down. So this is your deflection area here, and it allows the slab and the services to move freely with the fire stopping remaining in situ. So again, all these elements have to be considered when we're looking at this. There's also a group which has been put together it's in conjunction with a lot of the tier one main contractors. So Mace, Morgan Sindall, Waits, Lang O'Rourke, all those kind of guys have come together to put together what's known as the Passive Knowledge Fire Group. And again, it's something that they're looking at in terms of trying to essentially remove the requirements for three-sided letterboxes and the deflection into those openings. One of the big things that we have to consider is movement does not form part of the fire test standards at the moment. So if you have a movement seal, we can test to the principles of a moving wall, but it doesn't form part of the standard. So we have nothing to essentially test it to in the standard. So again, there's always a bit of a grey area around movement details, essentially being classed as ad hoc details because they can't be tested to the current standards. As I said, I appreciate this is a bit of a whistle-stop tour through a lot of some of the common issues and common errors that we find on site, and I'm hoping we've picked up on quite a few of these, and we'll sort of raise a few questions when you're next out on site or looking at a project, and I'll hopefully go through some questions and I'll try and answer as many as I can. I've seen some bits and pieces popping up, so it looks like there's quite a few to go through. Stephen, are you happy to go through those?
Absolutely, Aaron. So if you just want to, if you go to the Q&A tab at the top, if you just want to start going through them, that's probably the most efficient way of doing it.
Okay. So recommend all buildings low risk commercial have a fire strategy. Determine compartment walls and older buildings, sleeping accommodation is different. I'll be honest, Dominic. Yeah, I mean, fire strategies for every building, it's one of the first things that we ask to have a look at if it's available. I think you're kind of just guessing a lot if the building doesn't have a fire strategy that's been clearly defined and clearly set out. It's one of the big things that we as a manufacturer will always push the client to have a survey done of some kind to essentially look at if there's a fire strategy can be put together or offered to them as a client, because otherwise we're just guessing and we're just trying to help as best as we can, but without a fire strategy it's very difficult to really advise in any kind of compliant way. Hopefully that answers your question. Sorry. So yes, fire testing standards. So the ones that we predominantly will look at is EN 1366 Part 3 and EN 1366 Part 4. So Part 3 looks at service penetrations and Part 4 looks at linear gap seals. Part 1 and Part 2 looks at dampers and ducts, and I always forget which way around they are. Part 1 I think is dampers and Part 2 is ducts. Hope that helps. Does the A1 to E ratings supersede Class O for wall and floor linings, and is Class O still used? So Class O, it's probably not used as much as it used to be. If you look, it will depend on the product that you're looking at as well, because there's, it will depend if it's cavity barriers and things like that as well. They have slightly different variations on sort of the fire reaction ratings as well. I would say if you've got a specific question on the fire reaction side of things, if you could drop me an email after this, I'd be more than happy to kind of have a little look into if you've got more specifics on that one. Would you consider general fire stopping in the existing building to be notifiable through the gateway, replace expanding foam? I would not myself interested to hear the thoughts. So if the existing building, if it's going through remediation works and it has to go through the high risk sort of process and it has to go through the gateway, then yeah, if you're replacing expanding foam with a tested solution, again, it's always advisable. So in some cases, for like fire doors, for example, some fire doors have been tested with a with like an expanding foam and then maybe a mastic cap, or if it's a fire rated PU foam, it may have been tested in that format as well. But again, if it's falling under the process of being a high risk building, then yeah, any changes, even if it's sort of upgrading to the fire stopping, would need to be notified to the HSE and the BSR guys. Would you expect a contractor to be fire crested to install fire rated plasterboard? Now that's a really interesting question. So at the moment, it's not a legal requirement, even for fire stoppers, to be a third party accredited. So I'll try and keep it BBC. There are other UCAS accreditation bodies other than the FireAS available, like the IFC, BRE, etc. And it's something that comes up quite often. And worse, we look on site and the plasterboard's been installed absolutely horrifically. But the building control on site are very, very concerned about one cable that's been put through, and we've asked for 10 mil annulus and they've achieved 8 mil annulus around the cable, for example. But we're sort of saying, well, the fire rated wall will probably disappear in 20 minutes based on the way it's been built, and you're worried about the one cable with some fire rated mastic around it. The answer is no. Nobody has to be technically accredited to install fire stopping products, including dry lining. Now, the dry liners will obviously they sign up to different schemes than sort of FireAS, but it's something that we've raised this multiple times with sort of bodies, governing bodies and things like that, saying, well, actually, the wall is probably one of the most important elements. If the wall fails, then the rest of it becomes almost irrelevant at that point. So yes, in answer to that, unfortunately, no, they do not have to be FireAS accredited, but we are starting to see more and more dry lining companies becoming accredited installers of fire stopping. Policies in place for all alarm installations. Fire alarm systems are overtaken. There appears to be no fire stopping in place. So again, this is a lot about education and sort of O&M manuals as well. So especially if fire alarm systems are being installed after the sort of main M&E systems have been installed, we see this a lot on site. We actually saw one last week where the fire stopper had installed, bat mastic and all the gubbins that he needs to install. We went to have a look at another couple of installs that he'd done just down the corridor. We came back to take a couple of photos, and in that point, the fire alarm electrician or the fire alarm installer had punched a great big hole through the bat as it was still wet. It hadn't even dried, and they punched a great big hole to pass a cable through the opening. So I'm not aware of any regulation at the moment for fire alarm installers. But again, this is where it kind of comes back to the Building Safety Act. It comes back to project management and that education on site of saying, as a fire and stopper installer, they will take a picture as soon as they've installed their fire stopping. They will take a picture of, this is how I have left it, and this was compliant when I walked away from it. If that's damaged 10 minutes later, that physical proof shows that the alarm company or whoever it is, the Sky or BT, has decided to punch a hole through that. Again, this is where the stickers come into place, that it says, if you damage this seal, please contact the installing company or the site team to make them aware that it needs to be repaired. Again, I think a lot of it is down to education. It's that, oh, I've always done it this way kind of attitude is what needs to change quite dramatically, and we're fighting that a lot with the M&E teams at the moment, because we're now dictating to them what they have to do to make sure that they're compliant with our side, rather than us trying to work around their way of working with installations. Would you consider general fire stopping in an existing building to be notifiable through the gateway into tested solution, filling cable penetrations? Sorry, I think I answered that one. Pink foam and how fire riskers go about incorporating this into fire risk assessments accurately with educative information for clients and subcontractors. So, pink foam is a bit of an emotive subject. Generally, for the last 17 years I've been in the industry, we've been telling everyone that pink foam is the devil's work and it should never be used on site. And, that generally has got through. I'm kind of happy to hear that that's generally got through to site managers and project teams that pink foam is a big no-no, especially around service penetrations. Now, again, it's one of those things. I used to carry a lighter in my bag, on my site bag, all the time, and I'd always have an argument with the QSs or the site manager, and he'd be saying, "Well, it says on the front of the tin this pink foam is 4 hours fire rated," and I'd say, "Okay, I'll show you something," and we'd rip a lump of the pink foam off, and I'd hold a lighter under the pink foam, always outside, and it would generally disappear within 30 seconds to a minute into quite a horrible black cloud, and it would disappear. The reality is, pink foam has been tested, and I will not lie to you. We, as a manufacturer at Nullifier, do produce a pink foam. But the big thing that I always say is you need to read the test evidence. You need to read what it has been tested and how it has been tested. So, for example, we have a PU foam which has been tested around fire doors, timber door sets. Now, again, it's usually used as a remediation system. And again, our advice with fire doors, we always say, speak to the door manufacturer. Have they tested it with mineral fiber and fire-rated mastic? Have they tested it with a particular type of expanding foam? For example, there's a blue foam out there. I won't mention any names, but you've probably guessed what I'm talking about. The blue foam, again, it has a small variation to sort of standard systems. It requires intumescent packers. Again, the products are not always bad products. It's how they are used and how the test evidence and how they've been tested has been read and how it's been reviewed and installed. So pink foam isn't always the absolute devil's work, but generally, around fire doors and things like that, there are fire foam companies out there that have lots and lots of testing for that scenario, for that application. But if you see pink foam used anywhere around services, it's a massive no-no. Again, they have been tested in small linear gaps. It's normally like up to 20 mil, but again, the test evidence says that they have to be full filled all the way through the block work. So normally it's like 200 mil depth that they have to be installed to. And they can't be cut back in certain scenarios and things like that. So again, I can't stress it enough. You have to read the test evidence from that foam manufacturer. But as a general guidance, try to stay away from pink foam or blue foam or whatever colour foam it is. It's my general guidance. Is that? I think I've missed any questions.
There are a few more been posted at the top of the Q&A, Aaron, if you wouldn't mind.
Apologies. It's a brickwork. Oh, crikey, there's a few more coming through. System building. Okay, can you repeat fire testing standards again? Right, 36. So, can a building control officer or fire protection demand penetration seals are certificated? They can't demand it. It's only if the installing company that can actually certify that. So if they are third-party accredited, like FireAS or IFC, it is their choice if they can certify it. At the end of the day, it's them that are taking the sort of the liability of saying, yes, we've installed this as per the manufacturer, as requested, or as per their tested detail. So the BCO or the FPO cannot demand that a penetration seal is certificated. If they have any reservations, if the installing company has any reservations, that it can't be installed as per testing, then unfortunately it is down to them and them alone that it is certificated. They can call us in as the manufacturer, or they can call in, the certification body like FireAS to do a review, and they will take a guide on it, and if they're happy with it, etc., then so be it. But yeah, BCO or an FPO couldn't demand that they're certified, unfortunately. If there's a timber panel file 11 plus mixed use building, would you consider painting with intumescent varnish or paint? So timber and upgrading its fire rating. The simple answer to that is absolutely not. No. There are one manufacturer that springs to mind, and I won't name them, but they produce a number of paints and magic potions, is what I will call them, to upgrade timber and upgrade, in some cases, fire doors and things like that. I've not come across anything that has a properly viable, tested evidence that will help with this kind of scenario. I would very, very strongly recommend any kind of intumescent varnish or paint that is for upgrading timber. I would read it. I would check when it was tested. A lot of the testing that I see was done in like 1987. I was still in short shorts when that was tested, and yeah, the test standards and testing has moved on considerably since they were probably tested. My advice on that was no. I would very much stay away from intumescent paints or varnishes that go onto wooden boards and things like that. Building strategy, building generation, gens 38 doc useful. Ash, I'll be honest, I'm not overly familiar with that generation or Gen 38 document. If Thomas is happy to drop me an email after that, I'd quite want to look into that actually, and if I'd have a conversation with Thomas on that. So I'm not aware of that document, so I'd like to touch on that offline if that's okay. Fire rated compound made into a brick to make it associated with fire stopping services. Fire testing bricks. Building compound, fire rated compound into a wall scenario. It's something that we've looked at. I know there is another manufacturer, one of the big manufacturers, that has looked at it. I think they've got it more as an ad hoc type detail where you're building like fire rated bricks to sort of build it up like a brickwork. Again, the potential issue with that is you creating more potential breaches within that fire compartment seal by having the gaps between each brick. Normally, what they say is you shutter the opening in the wall, you create like a little letterbox at the top, and then you will pour it into the opening to create essentially a solid slab. And at the end, when you have that little letterbox, you would create a trowel grade consistency and then infill that small little letterbox at the top of the shuttering as the final element of fire stopping in walls. But again, it's something that we can propose to our R&D team, but it's something that we've been asked for quite a while. I know that London Underground use compounding walls quite a lot. But yeah, I'll take that back to our R&D team, and I will push that for you once again, because I know it would help on quite a few scenarios. Single-sided solutions, communal sides and penetration, current details, restrictive using letterbox details. So yeah, Scott, it's something that we would like to do a lot more testing with on single-sided solutions. So again, where you have properties where the tenants, they don't want to decamp tenants out of the properties and things like that. It's something that we've looked at. It's something we've actually recently just tested within shaft wall. So rather than creating a letterbox within the shaft wall, we've actually tested it in the lining of the corridor side plasterboards. And we've done some tests in Europe as well, where we've tested essentially a plasterboard where it's unfinished. So we've essentially built a plasterboard wall, but we've taken off the sort of the back side of the plasterboard on the fire side. So again, the biggest issue with this is, again, the standards. So the standards say that it has to be a symmetrical wall build-up. whenever you do a wall test, or it has to be a sort of compliantly built wall. So again, it's proving slightly difficult with the standards and sort of how we approach it to make it a tested detail to the standards. Partial penetrations where you have hockey sticks, that's another common one that comes up, and the ASFP are currently working with the sort of governing bodies to write that into the standards and things like that. So yeah, it's one I'd love to have a lot more information on, because it would solve a hell of a lot of problems on site. The problem is we have to worry about the fire getting into the compartment and potentially spreading up into the lining of the plasterboard. Spending part of the car do not provide enough space for the required amount of annular for the correct fire solution. In situ, see it attempts of fire inspections, none of which are compliant. Provide tested solution. So suspended ceilings above cross corridors. So again, suspended ceilings, unfortunately, they do become they fall sort of in some cases between ad hoc and best endeavours. So we can provide evidence with a plasterboard substrate up to a concrete soffit, for example. Again, it's very difficult to actually test a suspended ceiling in a fire test rig, because of the way the fire test rigs are built. It's almost impossible to actually build it in a rig to actually physically test it as it would be on site, if that makes sense. So yeah, again, we do have an ad hoc detail that we put forward, but yeah, it's one of those ones that then falls back to the fire engineer to accept, unfortunately. But again, we're kind of limited by the test rig simulations and the standards as well. So it's not through want of doing it, it's more of our kind of hands are tied with what's actually physically possible and theoretically possible under the standards. Sorry, Stephen, am I going over time here?
That's absolutely fine. We have come to the end of it. If you're happy to end it there, Aaron.
Yeah.
Absolutely. Right. Well, thank you very much. Guys, if you are wanting to claim your CPD certificate, you will need to click the link, which can be found. It's been placed by Ash in the chat. It's pinned at the very top of the chat bar. You will need to complete that in order to claim your certificate. So please do that before you exit the Teams call. We would like to thank Aaron for a fantastic presentation and for sharing his experience and knowledge with everybody. There's been a lot of thanks and good jobs coming through, Aaron, and we really do appreciate it. It was very, very informative.
Thank you guys for listening.
Please accept our thanks for joining us today, guys, and thank you to Ash at the IFSM for setting all this up. Fantastic job. Okay, see you all again. Thank you.